Bienvenidos a la ASERSA Open Webinar Series 14, con el que cerramos este 2022. Un espacio organizado por ASERSA y por aguasresiduales.info, donde pretendemos poner en valor la regeneración y la reutilización del agua en nuestro país. Soy José Miguel del Arco, buenas tardes a los que nos seguís desde España y Portugal, y buenos días a los que lo hacéis desde América Latina, y gracias a todos por vuestra asistencia, un ASERSA más. Antes de dar paso a Rafael Mujeriego, presidente de ASERSA, para que nos presente a nuestro invitado de hoy, permitidme que os comente que la webinar está compuesta de una primera intervención donde hablaremos sobre los enfoques adoptados por las agencias de agua del sur de California para superar las condiciones actuales de sequía, y una segunda intervención donde haremos una recapitulación de los ASERSA Open Webinar Series celebrados hasta el momento y donde conoceremos la nueva marca de ASERSA para promover la regeneración y la reutilización del agua. El primer espacio tendrá una duración aproximada de unos 40 minutos y a la finalización del mismo abriremos un espacio de dudas y consultas, y el segundo espacio durará unos 20 minutos y contará también con una breve ronda de preguntas. Mi compañera Tina estará coordinando el chat para cualquier cosa que necesitéis durante la tarde, y el material de hoy recordad que lo tenéis en la pestaña de App en Compartir medios. Y ya sin más, doy paso a Rafael para que nos presente a nuestro invitado de hoy. Buenas tardes, Rafael. Activa, por favor, el micro, que te tengo cerrado el micro.
Perfecto.
Estupendo. Adelante, Rafael.
Buenas tardes, José Miguel. Muchísimas gracias por la bienvenida. Es un placer estar una vez más de la 14ª sesión con vosotros. Es un placer compartir esta plataforma y este medio de comunicación al que llegamos con motivo de la pandemia. Ahora hemos salido de la pandemia, pero seguimos igualmente satisfechos. Para mí es una satisfacción hoy presentar a nuestro invitado y voy a hacer una doble presentación, unas imágenes aquí en lengua inglesa para los que puedan leerlo, y voy a hacer mi presentación en español para los que lo puedan escuchar. Vamos allá, pues. En primer lugar, buenos días y buenas tardes a todos. Bienvenidos al webinario número 14 de ASERSA. Déjenme que pongan aquí. Muchísimas gracias por asistir a este nuevo webinario, el cuarto de la Open Webinar Series 2022 de ASERSA. Como muchos de ustedes ya conocen, el objetivo principal de estos webinarios es compartir y divulgar los más diversos proyectos que se están llevando a cabo para hacer de la regeneración y la reutilización del agua un elemento básico de la gestión integrada de los recursos. Este webinario número 14, ¿debo de pasar la página? No, ahora. Este webinario número 14 ha sido posible gracias al apoyo de nuestros 5 socios protectores, la Agencia Catalana del Agua, la empresa Aguas de Barcelona, el Consorcio de Aguas Costa Brava Girona, la Entidad de Saneamiento y Depuración de la Región de Murcia, ESAMUR, y la empresa Veolia España, además de todos nuestros socios de número. Igualmente importante ha sido el interés y el apoyo que nos han ofrecido tantos de nuestros amigos, colegas y profesionales del sector de la regeneración y la reutilización del agua. Todos ellos han estado dispuestos a compartir con nosotros sus conocimientos y sus experiencias sobre cómo implantar y cómo llevar a cabo la reutilización del agua bajo las más diversas condiciones ambientales, sociales y económicas. La siguiente, perfecto. El webinario de hoy cuenta con las aportaciones de un invitado de excepción, Shivaji Deshmukh, director general de la entidad Inland Empire Utilities District, una compañía pública, una empresa pública de agua que atiende a unas 900.000 personas que viven en el sur de California. Una de las actuaciones más relevantes del Inland Empire Utilities District en este momento es atender la imperiosa necesidad de implantar la reutilización potable indirecta del agua como forma de compensar la drástica reducción de trasvases de agua que reciben desde el norte del estado. Han pasado de como él nos indicará, como Shivaji nos indicará, de un 30% a un 5%, todo eso debido a la intensa sequía que, de nuevo, afecta tanto al norte como al sur del estado. Nuestra más cordial acogida a nuestro invitado de hoy, Shivaji Deshmukh, que ya nos había atendido en nuestro segundo webinario de septiembre 2020, el primer año de la pandemia. Han pasado 2 años, en un momento en que la sequía se iniciaba, ese segundo episodio de sequía prolongada en California. Tenemos un gran interés por conocer las actuaciones llevadas a cabo y las propuestas de actuación del Inland Empire Utilities District para superar las reiteradas e intensas sequías multianuales que están registrando. Having said that, Shivaji, you are mostly welcome. You have the floor. Please go ahead.
Thank you, Rafael. Good morning from Southern California. I want to start off by thanking Rafael and Jose Miguel for the opportunity to speak. I had this pleasure about 2 years ago, as Rafael and I were remembering, and so I'm very happy to be here. I would much rather be there in person, but maybe we'll save that for the next time. I do have a presentation that is being pulled up right here, and I want to share an update of what's going on in Southern California in regards to the drought and what our agency in Southern California is doing to address that. So thank you again, and I'm looking forward to providing this presentation. California is very unique in regards to how we manage water supplies. For those of you who have visited, this is a cartoon of our state. We are one of the largest states in the United States of America, and essentially 2/3 of our population lives in the south part of California. That's where the city of Los Angeles is, city of San Diego, our 2 biggest cities down here in Southern California. The great imbalance of California water is that while 2/3 of us live in the south, 2/3 of the water falls in the north part of the state. So the federal government, along with the state of California, over the 20th century, has invested significantly in conveyance opportunities to bring water to where the people are. On this map, you'll see 4 different projects that have essentially been built to convey or transport water from either Northern California or the Colorado River to Southern California. In addition to bringing in imported water to Southern California, over the last 50 years, we've done an excellent job in terms of taking advantage of our groundwater supplies, desalting brackish supplies, and ultimately recycling wastewater, normally discharged to the ocean. And we are very proud of our history in Southern California in developing these local drought-proof supplies. For every gallon we're able to produce locally here, that means it's 1 less gallon that needs to be imported from the Colorado River or Northern California. And that provides a great opportunity not only for our region, but also for the state and the entire Southwest in the United States. Where I work is called the Inland Empire Utilities Agency. And as Rafael mentioned, we're an agency that is responsible for just under 1 million people. We are located about an hour east of the city of Los Angeles. And as you all know, Southern California, the city of Los Angeles is a very large urban area. Our area is a bit unique in that we have a high amount of agriculture and dairy. So we have a number of farms as well as cows here, and which is quite unique in Southern California because it's highly developed. However, we are going through a significant transition over the past 2 decades, converting from agriculture and dairy use over to residence and business. Affordable housing is a big challenge in Southern California, and with all the new housing opportunities in our area, it really allows and creates opportunities for Southern California residents to be able to live close to their work. We have 7 major cities in our area and just over 600 square kilometers. I want to apologize. I did our best to include metric units, but as you know, in America, we still are constrained by some of the English units, which is quite confusing. At the Inland Empire Utilities Agency, we do a very good job of developing a wide portfolio of water supply opportunities. One of the things that we've done quite early in the agency's history is recognize that sewage and wastewater are not waste products. They are an opportunity to recover valuable resources. And if you think about wastewater simply as solid, liquid, and gas, we're able to recycle all three of those elements as part of the wastewater stream. So all of the water that comes into our wastewater plants is recycled to a very high quality, tertiary quality water. All of the solids, the biosolids that are recovered through our primary and secondary treatment, ultimately digested, turn into a high quality compost at one of our facilities, where we take the biosolids that have been treated, mix it with soil amendment, and 2 weeks later, it's a very high quality compost, good for landscaping and agriculture. And then we don't produce 100% of our biogas off of our systems. However, we're working hard to achieve that number, ultimately, therefore, recycling everything that comes through our plants. In addition to managing a wastewater system where we recycle all the water, we also are a member agency of the Metropolitan Water District of Southern California. And they are the largest water district in the nation, responsible for bringing in imported water from the Colorado River and being the largest customer on the state project system. What that does is allows us flexibility in terms of how we manage water supply during droughts. And currently, we're in the worst drought period we have seen in many of our professional history. So while there are challenges right now, we are aware of solutions that can help navigate through this drought. And so I'm going to be talking a little bit today about the current status of the drought, and then ultimately what we're doing to address that. In addition to talking about water supply programs, one of the things that we're very blessed with in this region is a large groundwater basin. And these groundwater basins are extremely important when it comes to water storage and reliability. They are more important now more than ever because of the challenging drought period we have, combined with the effects of climate change. As we all are experiencing, climate change is going to result in longer, drier periods, but also shorter, intense periods of precipitation. And that's why storage is extremely important, to take advantage of capturing that water when it is available. As I mentioned before, we are a wastewater agency that collects and treats about 74 million cubic meters a year. And our job is to turn all of that water into recycled water. So while we buy imported water from Metropolitan Water District, we also recycle all of that water where it's either used for direct use on golf courses, lawns, medians, or the water is recharged into our groundwater basin. You can see on the right here some of our purple pipe. This is a color distinction that's been attributed to recycled water. This approach has been around for 50 years. One of the things we're very proud of in Southern California is we came up with a lot of these concepts and regulations. And as my colleague, Dr. Mujeriego, with his time here, him and his colleagues were really the ones who were promoting recycled water and allowing it to be used on agriculture and other irrigation needs, which really set Southern California up as the leader in this area. We are fortunate to have a number of treatment plants throughout our service area. We've identified 5 here. And like I mentioned, very approximately in English units, we're about 50 million gallons per day of treatment. But having these decentralized facilities affords us a significant amount of flexibility in terms of rerouting flows, should we need plant maintenance or improvements. And also when we're doing significant construction, we're able to use other plants and their extra capacity to accommodate that. As I mentioned before, our recycled water, and in our introduction, we talked about the concept of indirect potable reuse. So all the water that comes out of our plants is recycled. And while some of it is used for non-potable needs, we also take advantage of capturing this water in recharge basins, as shown here in this photo. And that water settles into the groundwater basin simply through gravity. We have been doing this for over 20 years now, quite successfully. We have 18 recharge sites within our service area. And not only does it capture recycled water, but it is able to capture runoff from storms, imported water if it's available, and all of that water gets commingled, gets recharged into the ground, ultimately to be used by our customers in our service area. I'd like to talk a little bit now about the challenges we're having when it comes to drought and water supply. I believe in in Spain, you have a very similar climate and therefore some of the same challenges we have. And this map that we show here, we've been pretty consistent for the past 4 years in experiencing moderate to extreme drought throughout the state. And as I mentioned before, it's important for us to recognize that the whole state is connected. So technically, if there was a drought in Southern California, in the lower part of the map, that would be a less priority or less important for us than if there was a drought in Northern California. Our goal is to make sure it rains in the north because we have the conveyance abilities and the pipelines to bring that water south. Because of this challenging drought in the state system, California as a state had to allocate water supplies to a number of agencies that receive state project water. And what that means is for any agency like ours that purchases imported water specifically from the state system, then we would be put in an allocation. Essentially what that means is that we've been cut off from about 50% of our imported supplies. Fortunately for us, we have two solutions out of that in the current time. That is to increase the amount of outreach and conservation that our customers perform. And the other is to shift our demands from imported water to the groundwater basin. So while that's a temporary solution, that is not a sustainable one, as we will continue to draw down our aquifers and put ourselves into greater risk. So we have to think about long-term solutions that'll help protect us from these future exceedances or droughts. This map shows you how our region has been tracking with that reduction in imported water supplies. And while we've been given a specific limit or goal, we have been consistently under that. Like I mentioned, we'd like to be proud and think that this is all conservation, but unfortunately, some of it is just shifting over to our groundwater supplies, which is not a long-term solution to this issue. The state of California is only one part of the water picture throughout for Southern California. The other thing we have to consider is the Colorado River. The Colorado River is one of the most important rivers in the United States from a water supply standpoint. It provides water for 7 states and 10 Native American tribes. This river also provides water to the country of Mexico. So therefore, it's a very managed and monitored river system. And as we were experiencing challenges in the state, we recognized, working with our partners throughout the nation, that the Colorado River had significant challenges as well. Right now, the lake levels in the systems along the Colorado River are extremely low. In Las Vegas, there is a lake called Lake Mead that sits behind Hoover Dam, and it's one of the largest storage reservoirs in the Southwest. Currently, it is so low, they're discovering old boats, remains of humans, and there's a lot of pretty interesting stories that connect to Las Vegas and that are literally being surfaced up because of the drastically low levels in the lake. While that creates stories and very interesting narrative, the most important part is that our supplies are going down to extremely low levels that impact the ability to intake those into the pumping system. In addition, on the Colorado River, when levels get very low in the reservoir system, our ability to generate power decreases significantly. And the Colorado River provides a significant amount of electricity throughout the Southwest, including, I believe, about 100% of the supply for the city of Phoenix in Arizona. I recognize there's a lot of words and letters on this slide, and it's not meant to be read, but I wanted to just review at a high level some of the immediate conservation actions that our region is taking, from the federal or United States level down to our local region. On the left, we look at what the US government is doing. Next, we see what the state of California is doing. Then we look at what Metropolitan Water District is doing. And finally, what we're doing at a local level. And for us right now, the real focus is on removing outdoor grass or turf, as we refer to it. Having grass in a California environment is not productive because it requires a significant amount of water that we literally will import. So our big push right now, our focus, is to work with retail agencies to the customers and say, do you really need all of this grass? And ultimately, we anticipate the state of California will ban that kind of grass in the next few years because of the significant impact it has on water supply. We refer to that as non-functional turf. So you may see that nomenclature or reference in some of these slides. Right now, like I mentioned, our biggest priority is to work with our retailers on how the communities can conserve more water. But we really feel that if we're able to remove a significant amount of this grass, then our water demands would decrease significantly. So we have to do more than that. And while conservation and use of the groundwater basin are temporary fixes, we do have some long-term plans that essentially increase the amount of recycled water that we produce and take advantage of the groundwater basin to store that water. Fortunately for us, approximately 7 years ago, the residents of California voted to spend over $2 billion US dollars on storage projects throughout the state that would increase water supply reliability and also balance environmental protection. So in 2015, we applied for funds to help build some of our projects. And what we suggested is that if we built more recycled water projects and got that water into the ground, we could allow for the state to keep water in the Feather River in Northern California and protect the salmonid species. So the state and the environment win by having more flows in the north. And then our area can benefit off of a significant financial investment into developing new recycled water. And currently the state has allocated us $215 million US dollars to build our facilities. And so we're very grateful for that partnership. And this really, if we had that program in place today, we would be able to navigate through the drought and have no impacts to our customers. So I'm going to talk a little bit today about how that program works, and that is what's known as the Chino Basin program. Before I go into that, we have a simple cross-section here of a groundwater basin and how it's connected to our river in our service area. And while this is a very simple chart, it's very important to see we take advantage of the storage in our area, whether it's stormwater, recycled water, or imported water. We will make sure that water gets in the ground so that we can use it on the days we need it. In addition, we are reaching the capacity with those recharge basins, and it's very difficult to find land because it's extremely costly, and our communities want to use that for residences and businesses. So we are converting, as we move forward, into large recharge basins, into smaller and smaller sites, which turn into injection wells. And in order to treat or to inject water, recycled water, it needs to be advanced treated. So all of this marries up to the project that I'm going to be talking about now, which is the Chino Basin program. We do still rely 30% on imported water to come into our area. And basically what the state of California has asked us to do is to reduce that, and they'd be willing to give us a certain amount of funding to allow for that investment. In order to get more of that recycled water in the ground, we do have to apply advanced treatment to that, which is basically reverse osmosis treatment. Our partners to the south, Orange County Water District, have been doing this for almost 15 years. Actually, they've been doing it for almost 50 years with Water Factory 21, built in 1975. And that was the first time wastewater was treated with reverse osmosis and then injected into the ground. We want to do the same thing in our service area, not to the same size, but to about 15 million gallons per day of treatment. So the Chino Basin program includes building 15 million gallons per day of advanced treatment in Southern California. It includes injection wells to get that water into the groundwater basin. It also includes extraction wells so that we can pump that water up, as well as pipelines to move it around our service area. What this does for us is it really increases the local control of our own drought-proof supplies in Southern California, and it allows us to keep more water in the environment, in the river, protecting the habitat for many fish species in Northern California. This is a busy slide, I apologize, but what it does show is the number of facilities and the amount of infrastructure required for the Chino Basin program. Once again, I apologize, I don't know the best terms to use, but I tried to put it in metric, and that would be approximately 21 million cubic meters per year of advanced treated water, all being injected into the ground. In addition, we need to have extraction capacity. So we would have almost 500 cubic meters of extraction capacity for the groundwater basin, allowing us access to that water. The beauty of a groundwater basin and potable reuse and recycling is that it is essentially another treatment step. So while the water goes in as recycled water, when it's pumped out, all it requires is a bit of chlorine and it's ready to be introduced into the potable water distribution system. So this is another step in the direction of potable reuse for our region. I would point out too, if you look at the map, while this is our service area, there is a blue line that circles the groundwater basin. It may be a bit hard to see, but our service area overlies the Chino groundwater basin, and that's what's delineated by that blue line. So that concludes my presentation today. I did want to close with just an update on the program. We continue to plan for this. We have not started construction yet. Our board has to decide in 2023 if they want to move forward with this project. We anticipate the total cost of the project will be about $1 billion US, and with a quarter of that being supported by the state, it is a very important and large financial decision. And so because of that, we continue to plan for it and determine what the overall cost benefit of the program is. After that, we'll provide our recommendations to our board. That concludes my presentation. I'd be happy to answer any questions now. Rafael, Jose Miguel, thank you. Thank you.
Thank you, Shivaji. It was a pleasure to listen to you and to see all these initiatives and the way, the methodology you are following just to proceed ahead. You are really planning for the future. It's nothing, of course, as you mentioned, if you had those facilities now, you would be in much better shape, but there's no need to get anxious or to get really upset. All you have to do is start working from day one and proceed ahead on a steady and systematic way. And I think you put forward very clearly what you are going to do with this round figure you mentioned, about $1,000 million to produce, I don't remember exactly, I think you mentioned 60 million cubic meters of recycled water that you can inject and then you can extract. So, looks great to me. Next time I will be visiting you, I will be going there and see if I can drink some of this wonderful water. And now, having said that, I will open the floor for questions. José Miguel, si tenemos preguntas.
Sí, Rafael, ya tenemos una primera pregunta por aquí. Recordad que nos podéis ir dejando vuestras consultas en castellano. Yo se la paso a Rafael y Rafael se la pasa a Shivaji y así pues rápidamente lo resolvemos. Nos preguntaba Leticia, Rafael, lo siguiente: si se elimina el césped y se prohíbe, ¿se utiliza algún otro tipo de vegetación como sustituto? Ella dice que entiende que las plantas y el suelo pueden retener la humedad y evitar la erosión y la desertificación y mejorar la sensación de aire fresco de la ciudad. ¿Cómo se está llevando a cabo este tema?
All right, Shivaji, the question is, before, let me say, next time, I'm sure Shivaji is going to be fluent, so I will not have to do this kind of translation.
I can understand, actually, if the grass is removed and banned, is any other kind of vegetation used as a sub? I'm reading the English part here, so.
Perfect.
But I did,
so yeah. you already have the question. Please go ahead, Shivaji.
It's a great question. I'll just repeat it in English, in that if the grass is removed and banned, is there any other kind of vegetation used as a substitute? I understand that plants and soil can retain moisture, avoid erosion and desertification, and improve the feeling of fresh air by the citizens. This is an excellent point that we, as a community in the state, have only learned recently how to do it better. So, for example, 5 years ago in the last drought we had, we really looked to cut back irrigation outdoors. And we very quickly realized that is not the right approach, because we could see a significant amount of vegetation and, more importantly, the trees dying off. So we need to make sure that there's a balance in terms of irrigating the existing the vegetation that we have and the trees that we have to preserve, just like this question says, the ability to create fresh air, clean air, have a natural environment. What we're suggesting is that in areas that are of new development, especially ours, where we have a lot of new houses and residents, that people think about what they install. And it does not have to be a desert landscape. It should be one that's more drought tolerant and local and native plants. For example, everything doesn't have to look like cactus and sagebrush. There's a lot of opportunities that we have in terms of different coverings. One of the things we're working with the agriculture industry is, are there grasses that use less water? But ultimately for us, we're trying to find that balance of vegetation that is native, that provides for fresh air and low water use, and doesn't force us into a non-natural landscape of just rocks and cactus. So I really appreciate the question. The challenge is finding that right template or portfolio. And ultimately, we have to think about the cost of it. If you're a resident with a relatively small house, sometimes to remove all of that grass could be $1,000 or $5,000. So our approach is to give a subsidy to that and then provide options of different planting. I would love to show some pictures of the way we do it, but we have a lot of opportunity here to change that. So thank you.
Shivaji, if I may add to this question, just to quantify these subsidies or this promotion, I understood it's about $1, $2 per square foot, which turns out to be about $20 per square meter of subsidy.
No, you got the number correct, Rafael, and sometimes local agencies like ours will add another dollar on top of that. So it's anywhere from $2 to $3.
Square foot.
Rafael, discúlpame, te voy a pedir en cada respuesta una breve conclusión tuya sobre la respuesta, porque tenemos gente que no habla o que puede que no entienda bien el idioma. No obstante, vamos teniendo más preguntas, pero te pediría que nos vayas haciendo un breve resumen, si no te importa.
Yo le decía a Shivaji que, a mi entender, en este momento, las administraciones locales, incluso Metropolitan, aporta $2 por cada pie cuadrado, que viene a ser $20 por metro cuadrado. Shivaji comenta que su agencia además añade $1 más, de manera que sería unos $30 por metro cuadrado. Y yo le quería comentar también a Shivaji, para él es lógico, pero para nosotros reconocer que el uso exterior, the outdoor use of water, is about 50% of your water consumption. So this educational program will have certainly a premium benefit. Ok. José Miguel.
Sí, continuamos. Rafael, nos preguntaba también María Coelho, ¿cuáles son los principales problemas de calidad del agua que encuentran al recargar el acuífero con aguas residuales recicladas?
Good.
Thank you. So the question I'm reading is, what are the main water quality problems that you find when recharging the aquifer with recycled water? Excellent question. One of the things I want to clarify is, right now we're going to recharge and inject different qualities of water. The recharge will be recharging tertiary quality water. Our quality is very high. However, it has a significant amount of salts in it, approximately 500 milligrams per liter of salt. Compared to other areas in Southern California, that salt level is relatively low. But our groundwater basin, we're very sensitive to the amount of salinity buildup. That's in the recharge basins. When we use the injection wells in the future, that water will be advanced treated by reverse osmosis, and that means it'll be about 100 milligrams per liter of salt. So we are doing our best to manage the salt. There was a related question about where the brines from the reverse osmosis is going to go. We're very fortunate that about 25 years ago, we built a brine line, a dedicated pipeline from Inland Empire that goes about 100 kilometers all the way to the coast in Huntington Beach, directly to a wastewater treatment plant. So we have the ability to put our brine streams into that dedicated line, and that's very convenient for us. It also allows for a lot of businesses to be created or to be situated along this brine line, because they take advantage of those discharges into that dedicated industrial line. But going back to the impacts of the groundwater basin, there's a few main considerations we're thinking about. First is the salinity, and that can be addressed by injecting RO-treated water, and we extract the brines through the pipeline. The other thing we have to think about with reverse osmosis treated water is that it is so pure that it could potentially mobilize groundwater contaminants that are existing right now. So that is why a rigorous monitoring program is important, to keep track of the water quality, and as the water is flushed out with this high quality water, that we don't impact our customers. Currently, we do have some nitrate problems in our groundwater basin. So we have pockets of wellhead treatment that allow for the removal of the nitrates. But essentially, we've got a relatively clean basin, and we want to make sure that the salt level is not building up there.
Muy bien. Perfecto. Adelante, José Miguel.
Sí, nos pregunta Adriana Romero, nos dice que cómo se van a gestionar las salmueras de osmosis inversa.
Rafael, this was the brine question.
Yes.
Yes. And so just to reiterate with the brine, we are fortunate to have that dedicated pipeline that's, like I said, about 100 kilometers long, and that allows us to put our brine in there. I would point out the more reverse osmosis treatment we do, the more brine is generated. We could exceed the capacity, and then it would be quite a challenge to figure out how to discharge that brine.
Si puedo complementar la respuesta,
sí.
Diría que ese conducto específico para las salmueras que van hacia la planta de depuración de Huntington Beach. En Huntington Beach entran en el emisario submarino que se diluye con otras aguas y que va finalmente al Pacífico. De manera que ese es el itinerario de las salmueras.
Rafael Israel nos preguntaba que qué tipo de desinfección utilizan para garantizar la salubridad de la recarga del acuífero, que si se han planteado tecnologías más innovadoras a los sistemas tradicionales de cloro, ozono o ultravioleta, como puede ser el ácido hipocloroso.
Okay. I think Shivaji can read that.
That one's a little harder for me to interpret. Could you help, Rafael?
Basically, the question turns around disinfection of the water that you are going to be recharging and maybe extracting afterwards, whether it's going to be based on traditional, conventional disinfection, or you are going to have new, advanced, different, non-conventional disinfection processes.
Yeah, the disinfection is, I would describe it as non-conventional, but over the last 20 years, more established post-reverse osmosis disinfection. We've found that a certain amount of chlorine or hydrogen peroxide along with ultraviolet light is the best post-reverse osmosis chlorination / oxidation step. So we refer to that as advanced oxidation. Our plan is to use either peroxide combined with ultraviolet light or chlorine combined with ultraviolet light. And what that does is two things. Not only does it provide another layer of chlorination or disinfection, which really isn't needed that much after a reverse osmosis, which is already removed your bacteria, your viruses, but it is another step in a multi-barrier approach. But the addition of the peroxide or chlorine allows for the oxidation process. So there are a number of low molecular weight organics like N-nitrosodimethylamine, NDMA, or 1,4-dioxane that do sometimes slip through a reverse osmosis membrane, and this advanced oxidation process helps address that.
Very good. José Miguel.
Rafael, nos pregunta Esteban que si se han realizado balances de energía para valorar el gasto en energía para la desalación y la inyección de agua en los acuíferos y las fuentes de suministro de esta energía que si son sostenibles.
Okay, good. Go ahead.
Energy use.
Yep.
So I'll talk about a few things, and then Rafael, tell me if I'm not addressing the question. But one of the things we think a lot about with water supply is the energy use to either treat the water or convey the water. So as I highlighted at the beginning of my presentation, a lot of the water that we get into our area comes from Northern California. And because it's literally pumped over a mountain range, it uses approximately 3,500 kilowatt hours per every acre foot of water. And while the acre foot is not a easy term to remember, it's an agricultural term that we use in the West, which is essentially an acre of property 1 foot deep of water. We do look at the amount of energy per acre foot. And as a comparison, if we, instead of moving water from Northern California at 3,500 kilowatt hours per acre foot, if we recycle it locally with advanced treatment, it's approximately 1/3 the amount. Even though we're using desalination techniques, reverse osmosis, to treat the wastewater, it's got relatively low salt amount in it, so therefore the energy is a lot less. As a comparison, if we were to desalt the ocean water here in Southern California, we anticipate that's about 4,500 kilowatt hours per acre foot. So from a climate change, greenhouse gas emission standpoint, we're very conscious of prioritizing those projects that can get us a water supply with a minimal energy use and therefore associated carbon emission.
Bueno, Rafael, y ya para terminar, nos pregunta Alberto que si existe colaboración con los vecinos y con los ciudadanos de Los Ángeles.
Another great question regarding collaboration with the city of LA and neighbors. The answer is yes. All projects in Southern California, when it comes to local supply, especially recycled water, requires partnership and collaboration. And right now, while our project is relatively small, the large water district in Southern California is the Metropolitan Water District. They're building a facility that would be 150 million gallons per day of recycling. And that's approximately 80 kilometers from where I work. They are willing to build pipelines that would convey that treated water all the way to our facility. So in about 10 years, we may have access to another supply of recycled water. And that would be as a result of a partnership with the city of LA and Metropolitan Water District.
Rafael, ya la última que acaba de entrarnos de Carmen, si se valora la eliminación de sustancias emergentes o productos farmacéuticos, plásticos, etcétera, en las recargas de acuífero.
You got it?
I think so. But like I said, correct me if I'm wrong. So I'm reading this as a question about how constituents of emerging concern, including pharmaceuticals, microplastics, are handled through treatment and the recharge basin.
Pretty good.
We're fortunate in that whether the water is treated or not through reverse osmosis, the groundwater basin is a great treatment and conveyance mechanism. We do extensive monitoring because of the amount of recycled water we use in this region. And what we have found is we have relatively low numbers in our tertiary quality water. When it comes to our advanced treated water that we plan to inject in the future, we anticipate significant removal of all of those constituents. Like I mentioned, right now there's a small number of chemicals that are regulated at a very low level that may pass through the reverse osmosis. And that is the benefit of adding an advanced oxidation step at the end of this process. We do look to our partners who have been operating these facilities for a number of years. That includes the Orange County Water District, who has been in operation for about 15 years at a large scale. And we have to recognize all wastewater is not the same. And so therefore, it's important for us as we build the next step that we conduct piloting and demonstration testing to make sure we really understand the matrix and the quality of our own wastewater.
Perfecto, Rafael, pues ya están todas contestadas. No sé si tú quieres aportar algo más antes de cerrar este bloque.
Sí, yo, por supuesto. I would like to share with Shivaji. There was two questions he may further explain. First of all, I would recommend to highlight even more the role of public education and outreach. This is something that is probably common and usual in everyday life for you, but it's something we have to emphasize much more than we do now. The other one is a more practical question, has to do with the kilowatt hour per cubic meter. You know, the numbers, the way we use the number with these cubic meters turn out to be very simple to remember. If I remember well, Orange County is indicating that they need 1.1 kilowatt hour per cubic meter, that bringing water from the north is about 2.4, from the north of the state, and ocean water desalination is just about 3.5 to 4 kilowatts hour per cubic meter. So if you like to send me later on those numbers expressed in acre foot, which I have always informed to our participants, that is equivalent to 1.1234 cubic meters, I can do the operation and convert it into regular numbers.
Rafael, these numbers are very consistent with what I have in my head, and essentially to get to the per acre foot, you multiply by 1,000, very, very roughly, right? You said it 1, 2, 3, 4. So these are the numbers that I have, and for me, it's easy to remember because it's basically 1 kilowatt hour per cubic meter for developing a local supply, 2 for importing it, 3 for ocean desal, and those are the metrics we use. So I agree with those numbers. I'm glad that you brought up the role of public outreach. And I would like to just tell a really brief story, and it's actually how Rafael and I met. Is when I started my career, I was at the Orange County Water District, and Rafael spent a year and a half there. And one of the things that we learned early on is that while we may have technical solutions to water supply problems, none of those will work if the public doesn't understand it. So for example, with the projects that we've been working on throughout Southern California in terms of making wastewater be converted into a potable supply, we know as a technical community that we can do that through reverse osmosis, through advanced oxidation, with microfiltration pretreatment. We know we can literally remove or create water. It just comes at what energy and what cost. But from the public standpoint, if we simply say, oh, we're taking toilet water and you're going to drink it without explaining anything, understandably, there'd be a lot of concern. So the water industry, I would say before the turn of the century, wasn't as focused on outreach. They were focused on technical solutions, and that's it. And we saw a number of very large, very good projects fail around that time in 1999, 2000, including the city of LA, city of San Diego. While they were good projects, they did not communicate to their public, and therefore the public was very concerned. So when we worked on these projects 20 years ago, it was very important that we prioritize getting out and explaining what's happening, explaining that all water is recycled, that we're dealing with the same water from when the dinosaurs roamed the planet. And what we found that in a 10-minute presentation, people really understood and got excited about drinking recycled water. And today we're in a very different paradigm or a different environment. It doesn't mean that we need to stop the outreach. It means we need to maintain that. So that's true for recycled water. That's true for conservation. That's true for watering your lawns. And ultimately right now, the public needs to understand where our water comes from. And that'll make them think twice about wasting water. So for us and the water community throughout the world, but especially here in Southern California, where I have experience, outreach, communication, working with the newspapers, social media nowadays, there's so many different tools for us to be able to share our message. And for us, we have a team of about 6 people who work on finding ways to promote what we do, because in the end, that's going to result in water savings for us.
Thank you, Shivaji. Let me say, just to close and allow you to go into your work, because I know this is the starting point for your day. It has been a real pleasure to share your experience, your knowledge, everything you do with us. I'm so happy that we have been able to overcome the airlines and the weather difficulties you had a few weeks ago coming to Spain. Now through video conference, we have been able to do it. So let's hope in the near future, we can make sure you can come over and explain what you will be doing at the time, which according to your planning should be perfect, enthusiastic. So thank you again. It was a real pleasure to have you among us today, and we look forward to have you again.
Thank you, Rafael. Thank you, Jose Miguel. Always good to see
Thank
you.
you.
And
Thank you,
thank you,
Shivaji.
everybody, for the great questions.
All right.
Thank you.
Have a good day. Bueno, José Miguel.
Sí, Rafael,
Sí.
damos paso ya al siguiente bloque. Denominábamos recapitulación de los ASERSA Webinar Series y después veremos la nueva marca de ASERSA para promover la regeneración y la reutilización del agua. Por tanto, te doy paso para que veamos esa recapitulación de los ASERSA que hemos hecho hasta el momento.
Bueno, pues muchísimas gracias, José Miguel. Ha sido un placer, ha funcionado todo perfectamente. Hemos tenido la comunicación por internet magnífica y ahora en un ambiente monolingüe vamos a comunicarnos quizá con más facilidad. Ha sido un placer ver que Shivaji se había preparado la aplicación para poder tener directamente la traducción, de manera que ha funcionado mucho mejor de lo que yo lo podría hacer. Yo querría utilizar esta media hora que nos queda, aparte de ofrecer la palabra a las personas que lo quieran aceptar, hacer un breve resumen de estos 4 webinarios del año 2022. El primero, si se acuerdan, fue una reflexión, una explicación de lo que se está haciendo en este momento en Santa Ponsa, en la isla de Mallorca, un proyecto emblemático para el riego, para la provisión de agua, para el sector hotelero, para los inodoros de los hoteles. También estuvimos hablando de la situación reglamentaria, legal, jurídica de la reutilización del agua y yo me quedé con la sensación de que mientras que avanzamos en los temas de técnicos y de relación con el público, los temas jurídicos legales progresan, por decirlo positivamente, progresan a un ritmo mucho más lento, por decirlo de esa manera. Segundo webinario, el webinario número 12, tuvimos una explicación de la actualidad de la reutilización potable directa en Windhoek, que no hemos de olvidar que es el proyecto pionero de todos, 1968, en el que por primera vez se introduce agua regenerada directamente en la red de abastecimiento, que es un paso superior al que nos está explicando nuestro colega Shivaji. Igualmente pudimos ver en una segunda sesión las iniciativas que se están adoptando en California, si se acuerdan lo que decía Shivaji. El norte de California tiene 2/3 del agua, hasta que ha dejado de tenerla en esta actual sequía. Ya no es que no llueva en el sur, es que tampoco llueve en el norte. Y ya está en el tercer año. San Francisco tenía asegurada su abastecimiento en la Sierra Nevada y en este momento ya está planteándose la reutilización potable indirecta o incluso directa. De modo que pasamos después al último webinario que celebramos en el mes de octubre, donde nos hablaron los colegas de Menorca, la iniciativa que se está planteando de utilizar, como hacen en el Inland Empire Utilities District, el recargar los acuíferos. Menorca es una isla muchísimo más, relativamente más minúscula que todo este condado que nos estaba hablando Shivaji, pero el concepto es el mismo. Y yo me alegro muchísimo de que esa idea esté calando, no solo por eso, sino porque igualmente pudimos escuchar aquí las presentaciones de 3 proyectos live dedicados a las facetas de la recarga de los acuíferos para distintos usos posteriores. Y finalmente el que tenemos hoy, dedicado a la reutilización potable indirecta en una zona de una sequía notable, multianual y de gran severidad. Yo tenía aquí anotado unas breves resumen de 4 puntos que yo le he denominado de interés, resumen de todo lo anterior, diciendo que hemos avanzado notablemente en la implantación de los proyectos de reutilización para usos no potables y en particular para los usos domiciliarios de suministro de inodoros, el caso de Calviá y el caso del Prat de Llobregat, que nos habían presentado nuestros colegas también de aquí, de Barcelona, hace ya algún tiempo. En segundo lugar, que la recarga de acuíferos con agua regenerada está despertando un interés creciente, un interés investigador creciente, en cuanto que puede considerarse como una forma de naturalizar, eso que nos decía también Shivaji ahora, de que sea agua natural, que ha pasado por un medio natural, pero además también como medio de almacenamiento, de regulación, en el término, la palabra regulación desde el punto de vista hidrológico, antes de que pueda ser utilizada nuevamente para otros usos. No potables por el momento, pero que posiblemente dentro de un tiempo pues, ha de considerarse como los potables. En tercer lugar, reiterar lo que ha manifestado Shivaji, este notable dinamismo de las entidades públicas y privadas con financiaciones de unos órdenes de magnitud que aquí no conocemos en California debido a la intensa y prolongada sequía que lleva afectando ya por segunda sesión de varios años al norte y al sur del estado, haciendo que las poblaciones que gozaban de fuentes de agua como San Francisco pues hayan de plantearse la reutilización potable y otras que lo venían contemplando en las proximidades, como es el caso de Inland Empire, lo tenían al lado de en Orange County Water District, donde Shivaji trabajaba y yo tuve la gran satisfacción de conocerle, pues ahora lo están incorporando también. Una vez más, esa recarga planificada ofrece una solución emblemática de renaturalizar y de almacenar. Y como bien ha documentado Shivaji, pues el coste de hacer eso localmente, que es como ellos lo denominan, una fuente local de agua, pues es más económico que traerla desde el norte cuando hay, porque cuesta como mínimo el doble de energía bombearla desde el norte. Y por último, en una de las presentaciones tuvimos ese proyecto de reutilización directa de Windhoek, la capital de Namibia, que sigue avanzando, que sigue desarrollando desde el año 68 en que fue construido e implantado. Y aquí hay que recordar, igual que está ocurriendo ahora en la ciudad del Paso, en Texas, que las fuentes convencionales más próximas están a centenares de kilómetros. En el caso de Namibia, 700 kilómetros al norte, en la frontera con Angola. De manera que eso ya, y en el caso del Paso también, 200, 300 kilómetros, significa unos costes de energía que se pueden invertir y se están invirtiendo en purificar el agua localmente. En resumen, yo resumiría todo esto que nos han dicho tantos colegas durante esos 4 webinarios, ilustran la adaptación técnica y de gestión progresiva hacia unas formas de hacer mucho más sostenibles y vanguardistas, aunque todavía hay que reconocer que la necesidad de utilizar ampliamente los estudios de gestión de riesgos capaces de asegurar la aprobación sanitaria de estas nuevas formas de hacer. Ha habido varias preguntas relativas a eso. Shivaji las ha respondido porque ya en estas empresas públicas se ocupan de ello, con esa oxidación avanzada, o un detalle que me he olvidado de preguntarle a Ere y que él también, por considerarlo normal, no lo ha mencionado, es un intenso programa de control de las fuentes de contaminación, de que ya no es cuestión de quitarlo una vez que está en el agua. La mejor manera de evitar la contaminación del agua es evitar que se contamine. Y eso significa que ellos van a los usuarios del tipo que sea, industrial, comercial o urbano o doméstico, y evitar que se produzca la entrada de ciertos productos. De manera que esa faceta también ha de ser encontrada, considerada como ayudante a evitar los riesgos. Y todo eso también, como ha comentado Shivaji, en un marco de colaboración institucional proactiva entre las autoridades de recursos hídricos y de salud pública, de una parte, y los usuarios, las entidades públicas del agua. De manera que he tratado de resumirles estos 4, me habían pedido varios colegas que hiciera este resumen de estos 4 webinarios, y quizá antes de presentarles las imágenes, que son simplemente 2 imágenes, quizá lo hago ahora y después pasamos al debate en los minutos que nos quedan, decirles que ASERSA se viene planteando desde hace algún tiempo unas imágenes que puedan aportar ese estímulo, ese conocimiento que nos decía Shivaji, que en 10 minutos una audiencia puede entender qué le hacen al agua desde que es efluente secundario hasta que es agua regenerada, y de esa manera conseguir su aprobación. Pues ASERSA está tratando de elaborar esa marca de calidad, y aquí les presento el estado de la cuestión, como se suele decir, a fecha de hoy. Esperamos que
ya nos ha dejado una, Alberto.
De manera que les presento estas 2 imágenes. Hemos llegado a esta imagen como futuro anuncio, indicador que pueda aparecer en los jardines, en las instalaciones donde se está reutilizando agua. De manera que aquí figuraría, este es el agua ya regenerada. Tenemos una versión, yo no la tengo en este momento, en donde la palabra esta regenerada pueda ser de color azul, que es la última fase de esa gota ahí simbólica que ven ustedes, en que se podría leer agua purificada, que sería esta que Shivaji nos comentaba como Advanced Purified Water. Agua regenerada, que sería prácticamente agua potable. De manera que este sería el logo anunciador de que se está utilizando agua, la reutilización propiamente. Y una segunda imagen que figuraría, sería un anuncio que aparecería en la planta de regeneración, en la estación de regeneración de agua, que tendría un aspecto como el que ven aquí. Aquí hemos utilizado la planta de Castel Playa de Aro como modelo, pero figuraría la que en cada caso convenga. E igualmente esta imagen cambiaría de colores, este color morado, con estación regeneradora de agua, y el marco que rodea Castel Playa de Aro pasaría a ser un azul marino, cuando la planta, esa estación, en vez de ser una estación regeneradora, sea una estación purificadora de agua. Es decir, que produzca un agua con una calidad superior.
Rafael, esta iniciativa, por tanto, ¿de cómo surge o de dónde surge?
Bueno, pues surge de la Junta Directiva de ASERSA y de los socios de ASERSA, que plantean pues la dificultad. Voy a resumir una anécdota que todo el mundo va a entender y la voy a hacer con todo el afecto posible a los medios de comunicación. Hace algunos meses nos solicitaron una entrevista para un medio de comunicación nacional a divulgar la importancia de la reutilización, y les facilitamos la entrevista. Y no nos hicieron ningún comentario de si queríamos aportar fotografías, pero el fotoperiodista de la publicación pues optó por incluir dentro del artículo, un artículo a 2 páginas en un diario nacional, la imagen de los decantadores secundarios. Yo entiendo que los fotoperiodistas en muchas ocasiones quedan maravillados por lo que puede hacer un decantador secundario, pero un decantador secundario con un efluente secundario no es ni agua regenerada ni es agua purificada. Por lo tanto, de ahí surgió un poco la idea de decir, vamos a hacer, ya la teníamos antes, acelerado el proceso, vamos a conseguir unas imágenes para que la próxima vez, el que la quiera poner, la ponga en su instalación y el fotoperiodista pueda hacer una fotografía de esto, sobre todo, si es posible, con un matraz de agua regenerada o de agua purificada al lado. Y de esa manera transmitir a los usuarios, al público en general, que estamos hablando de una cosa completamente diferente de un agua residual depurada. Esa era la idea. Y creo que con esto ya solo me queda despedirme, pero no me voy a despedir ahora. Ahora, si te parece bien, José Miguel, podemos abrir un pequeño turno de palabras o de cuestiones, si las hay, y yo encantado de atenderles.
Sí, pues tenemos varias preguntas que te voy a hacer ahora,
Adelante.
pero entiendo, por tanto, que nos animas a los medios de comunicación también que le demos difusión a esta nueva imagen, ¿verdad?, en las próximas semanas, y que entre todos ayudemos a que aquellos que estén interesados, pues que empiecen a usarla, ¿no? Entiendo.
Esto, como se diría en el lenguaje tradicional, es un tráiler. Cuando yo era niño se hablaba un tráiler de tal pregunta, de tal película. De manera que esto es un anticipo. Dentro de unos meses confiamos tener esto ya formalizado para que los medios, quien lo desee, la pueda utilizar tanto para ponerla en sus instalaciones como para hacer la publicidad y decir, estamos hablando de este producto, no estamos hablando de un efluente secundario que tiene su papel fundamental. El efluente secundario es la materia prima con la que se va a hacer todo esto. Pero queremos transmitir al público una imagen y sin duda estará a la disposición de todos vosotros.
Pues excelente iniciativa, Rafael, y cuenta con nosotros para que le demos la máxima difusión en las próximas semanas o en los próximos meses, una vez que ya nos comentes que está listo.
Sí.
Bueno, pues te voy a hacer un par de preguntas que nos han dejado por aquí.
Bien.
Alberto nos preguntaba que qué permite hacer la legislación actual en España y qué perspectivas a corto plazo hay de cambios. Entiendo con respecto a lo que nos ha comentado Shivaji esta tarde.
Estoy un tanto desligado de esos avances, pero a mi entender, lo más sólido que tenemos en este momento, y es más sólido de lo que pensábamos incluso hace unos años, es el Real Decreto 1620-2007. A fecha de hoy, eso es lo mejor que tenemos. Y es incluso lo mejor que tenemos con todas las mejoras que se le pueden hacer, que otros, mucho mejor que lo que tienen otros países que en algunos casos no tienen nada. Pero claro, he de decir también, muchos de nuestros oyentes, participantes lo saben, que en junio del año próximo, julio del año 2023, se cumplirán 3 años, no me lo puedo creer, de la aprobación del decreto del reglamento 2020-741 de la Unión Europea específico para el riego agrícola. Básicamente significa una mejora de la calidad, un nivel de calidad un poquitín más alto que el que tenemos ahora, y sobre todo introduce un reto que es el de elaborar esos planes de gestión de riesgo. No estoy al corriente de quién los pueda estar haciendo en España. ASERSA hizo su aportación en algún momento, está en la página web de ASERSA, la aportación que hicimos dentro de un proyecto europeo, pero no sé cuál es el estado y en teoría para junio del 2023 tendríamos que tener ese reglamento listo. Por lo demás, la realidad es que hay numerosísimos proyectos en Murcia, en la Costa Brava, en la Costa del Sol occidental, donde se está regenerando agua a un nivel de calidad más que satisfactorio para ese tipo de riego. Pero ahora le tenemos que dar ese matiz documental, demostrativo, de que cumple y mantiene los riesgos dentro de un cierto nivel.
Estupendo, Rafael. Y una pregunta muy interesante que nos hace Leticia Martínez, que nos dice que la salida de un terciario con membranas de ultrafiltración más ultravioleta, ¿se considera agua regenerada o purificada, Rafael?
Es una excelente pregunta que me permite, como se suele decir, engancharme a varias cosas. La primera petición que yo les haría a todos nuestros participantes es que dejen de utilizar de una vez lo de tratamiento terciario o como mínimo efluente terciario. Ese término no aparece ni en el Real Decreto 1620-2007 ni en el Reglamento Europeo 2020-741. Se habla siempre de agua regenerada, ni siquiera se habla de agua residual regenerada. Se habla de agua regenerada, de estación de regeneración o de instalación de regeneración de agua. De manera que yo les pediría a todos en ese sentido de comunicar con el público. Es decir, no estamos ofreciéndole a usted agua residual, depurada ni sin depurar. Estamos ofreciendo agua regenerada. De manera que terciario no está en ninguno de esos documentos. Y yo creo que conviene. Técnicamente, si uno quiere llamarle en los proyectos terciario, pues que le llame terciario. Yo he visto proyectos australianos que hablan hasta de tratamiento cuaternario. Bueno, yo ya no sé si cuaternario significa algo o no, pero por lo tanto, proceso de regeneración es lo correcto y es lo que debemos de utilizar para entendernos. La segunda respuesta, si recuerdo bien, es que ese proceso pasado la regeneración básica, ósmosis y oxidación avanzada, ese agua en California ya se llama Advanced Purified Water. En castellano lo podríamos traducir como agua purificada, sí, que es la que se utiliza para la recarga de acuíferos de uso potable. Sí.
Estupendo, Rafael. Pues no hay más preguntas. Sí que me gustaría leerte un comentario que nos deja Nelson Olivares en el chat y que nos dice: felicito al equipo de ASERSA por este encomiable esfuerzo buscando la sostenibilidad del recurso agua, juntando experiencias de todos los hemisferios y compartiendo el concepto no solo técnico, educacional y estatal para que podamos colaborar desde cada una de nuestras trincheras. Así que yo creo que es un comentario bastante interesante.
Yo le agradezco muchísimo a Nelson esa percepción positiva, que es la que nos ha de mover para seguir adelante. Yo, si me permite, José Miguel, tengo aquí unas palabras de despedida, porque entiendo que no hay preguntas más, y decir, pues nada, mi agradecimiento a todos a nuestro presentador de hoy, aunque ya ha debido de ausentarse hacia su trabajo cotidiano. A California va 9 horas antes que nosotros, de manera que allí ahora deben de ser las 9 de la mañana. expresar el agradecimiento a él, a todos los que han participado durante todos estos 14 webinarios, lo han visto después en vídeo, a nuestros socios protectores, por supuesto, y a todos nuestros socios de número, y a todos los que han hecho posible este intercambio de conocimientos y experiencias, porque eso es lo que estamos haciendo, compartir. Cada uno luego después hará lo que pueda, lo que convenga. Y muy en particular, pues quiero agradecer a José Miguel del Arco, que es el timón de esta plataforma que nos está permitiendo la comunicación. Yo les invito a todos ustedes a futuros webinarios el próximo año 2023. Podrán estar al tanto a través de la página web de ASERSA y también de aguasresiduales.info. Les animamos a que consulten periódicamente la página web asersagua.es, donde podrán conocer la actualidad del sector y la programación de actividades. Decirles también, como ya ha comentado José Miguel, que el programa completo del webinario este 14, igual que los anteriores, estará en la página web de aguasresiduales.info y en la página de inicio de nuestra propia página web, asersagua.es. Y llegados a este punto, y dado que estamos ya a las puertas de que se acabe el mundo, como se suele decir, en el mes de diciembre, pues desearles un feliz fin de año y un nuevo año 2023 lleno de nuevas satisfacciones personales y profesionales. De modo que hasta el 2023, mucho éxito, muchas gracias y un saludo muy cordial para todos ustedes. José Miguel, tiene la palabra.
Muchas gracias, Rafael. Muchas gracias a todos los asistentes de esta tarde y de todos estos ASERSA que hemos tenido en los últimos meses. Y nada, nos volvemos a ver otra vez, como bien dice Rafael, en 2023. Muchas gracias sobre todo a ti, Rafael, por estar siempre ahí. Un saludo y buenas tardes a todos.
Buenas tardes, José Miguel, y buenas tardes a todos.